In this video, we're going to discuss how to find the probability from a z-score. And so we know probabilities already, and we're able to find certain percentages underneath the normal curve if they fall on a standard deviation. And we're able to do that from the empirical world. What happens when we start to get z-values or z-scores that don't fall on the actual standard deviations? We can use our standard normal table. Remember, a standard normal distribution is just any normal curve that has a mean of 0 and a standard deviation of 1. So when we talk about the standard normal, we're really talking about a normal curve that has a mean of 0 and a standard deviation of 1. And the other thing we need to remember is that underneath any one of these curves here, underneath any one of these curves, is always 100% of the data or the area. So we're going to find area where we're finding 100, where we're looking at this curve as 100% of the area that we're looking at. So let's go ahead and try to establish the different percentages that we can find based off of z-scores. And what we're going to need is we're going to need a standard normal table. So make sure you have a standard normal table handy. Anytime you do any one of these problems, the first thing you want to do is you always want to shade a particular normal curve. So here are the different type of curves we can shade. And they're really based on these symbols right here in the middle on how you're going to shade these curves. So for instance, this first one says to be less than the z-score that you're getting. So whatever z-score you get on this curve, let's say your z is here. If I say less than, that means I want to shade everything to the left of that z value. So I'm going to shade everything back this way. And every problem we start off, we'll draw a curve and we'll shade it like this. So this is what we call a less than curve. If we get one more we have to shade and it's greater than, so we'll have a z value again, greater than means shade to the right of the curve. So you're going to look at that little bit of area right there. And one thing that's going to help us to remember that a normal curve, our mean sits at the middle. So the mean is always going to be 50% of the data. So if you look at something like this, we know that our percentage or our probability has to be greater than 50%. And that's a good guide for us. Likewise, if you look here, you can see that it's past the mean. You're looking only at this little bit of area. So it's going to be less than 50%. So it's just a good guide. Now, the other thing is we can find these between curves. And in between, you have two different z-scores you're looking at. And the way you do a between curve is you always calculate you find the area of the largest value first. So here you have a z that makes it here. Here's z1, and here's z2. What you want to do is you want to find the area of z2 first. So you go find on your normal table the area up to z2. It's going to put you out here. And we would shade all of that like this. Shade all of that. But we only want to find between z1. So we're going to find the area up to z1, which is right here. And we would shade all of this. And notice, all I've done is I've taken the purple, which was the whole thing, and I'm going to take away the blue. So what I'm really going to do is I'm going to take the area I get for z2 and the area I get for z1, and I'm going to take the difference of them. And that's going to give me the stuff that'll be left in the middle right here. So we'll get to one of those two in a separate example. So let's look at a couple examples. So let's look at these tables, and these are the actual standard normal tables that are given to you on an AP exam. And you'll notice that here you have a negative z-score table and a positive z-score table. And for both of these tables, though, notice that the shading is always going to be to the left of the z-score. So it's going to be to the left of the z-score. So when we have these right tail curves that we're trying to find, we're going to have to use things a little bit differently. But notice that on each one, the z-value starts from negative 3.4 on the negative side and goes to 0 here. Then it starts on 0 and goes over to 3.4 on the right side. And that's again because the z-scores themselves are underneath the normal curve. There's only 6 standard deviations. So really from negative 3 to positive 3 is where all your areas defined at. Anything outside of that is not going to be there. And when we read the table, we read the ones digit and the tenths digit together. And then the hundreds are going to be added on at the top up here. So let's go ahead and practice some of these, okay? So let's try to find the percentage of values that fall less than negative 1.27 on the standard normal curve. And what we're going to do here is we're going to draw a normal curve and we're going to label it with that z-score. So negative 1.27 is somewhere over here. And I'm going to shade that curve to the left. So I want to find that area there. And remember, I'm always going to use the mean as a reference here. So I know my area should be less than 50% because I'm lower than the mean. So I should be less than 50%. So when I go to my z-score, I'm looking at the negative table. I find the first part, negative 1.2, sitting here. So I'm going to highlight those values over here. Highlight the row for those values here. And then the next thing I'm going to do is I'm going to highlight the column for 0.07 to finish this off. That's here. And when I look at this, I see that I get a z value, or the corresponding ones that intersect, right here at 0.1020. So this is equal to 0.1020. And that answer makes sense because this is a very small portion of the curve that we're shading. So let's find the area of the right-hand side of the curve. In order to find the area of the right-hand side of the curve, we're going to use this problem here. It says find the percentage of values that are greater than, where the z-score is, find the percentage of values greater than a 1.75 as the z-score. So the first thing I do is I'm going to label this curve with 1.75. That falls about right here. I want to be greater than that, so I'm going to shade it to the right-hand side of the curve. Now, go to your table, and this time we're using the positive z-score table. So when I go to my table here, I'm going to go ahead and do 1.7 on the row. And then I'll do 0.05 on the actual column. And when I do that, notice that my z-score, there where they intersect, is at 0.9599. Now, when we look at this, though, we can definitely see from this table that this is nowhere near, or from this actual curve, that this is nowhere near 96% of the data. Because we know one thing, it's got to be less than 50%, less than 50%, because we're smaller than the mean value there. So one reason we need to look at it, we need to realize this, is that we've gotten this area because we're finding the right side of the curve, but this curve only gives me left-hand values. So one way to fix this is to take the probability I got there and realize that the left-hand side plus the right-hand side equals 100%. Well, if I want the right-hand side and I know the left-hand side, if I do 1 minus, or 100% minus 0.9599, I get 0.0401. That means that this percentage, or that area, is just 0.0401, and that answer makes a lot more sense. Now, the other thing I can do is I can realize that because this curve is symmetric, the same amount of area that sits at 1.75 also sits at negative 1.75. And the reason that matters is because if I do that, then I'm going to get the left-hand side, which would make this curve correct to what the table is showing. So the other thing I can do is, instead of using the positive z-score here, I could use the negative z-score. And if I go on this table again, and if you look at negative 1.75, which is going to be here, notice that that value there is this value of 0.0401. And that's because the symmetry of the curve allows you to look at both sides. And so when you do this, here's what you can realize. Anytime you do a right tail or a greater than, when you're looking at the right side of the curve, you always look at the opposite z-score on your table. So if it's a positive value, you want to look at a negative z-score. If it would have been a negative z-score like this, you would have looked at the positive z-score. In this last problem, we're going to look at it between curves. And between means you're looking at two z-scores, and you're trying to find the area between. And so for this, we're going to look at it between negative 1.2 and 1.63. So the first thing I'm going to do is I'm going to label my curve with those values. Negative 1.2 is here, and positive 1.63 is here. And the way this works is you always find the area of the larger z-score first. So I'm going to go find the area of 1.63, which is this area shaded this way. So I'm going to shade all this area to the left like this. So I go to my positive curve first. And if I look here on this curve, again, 1.6, and then 0.3. And it's going to be this value right here, 0.9484. So the probability that z is less than 1.63 is 0.9484. Then the other curve I'm going to go look at is going to be the negative z-score curve. And so when we look at this curve, we're going to look at negative 1.2. That means we're going to shade this area to the left of 1.2, negative 1.2. And notice what it did there. I found the red curve, and I found the purple, and I'm going to take the purple away. So that purple curve, negative 1.2, is sitting right here. This is the area. And this time we're right at 0. So it was 0.1151. This is 0.1151. And so if I want to find the actual area of the inside of this curve, I want to find this area on the inside, I can just find the difference between the two, the red and the purple curve. So here when I subtract off 0.9484 minus 0.1151, I get 0.8333. So the area between, or the percentage of values between negative 1.2 and 1.63 is 0.8333.